So previously, we have been learning how to multiply matrices and found that the matrix multiplication is not necessarily commutative. However, they satisfy the associative rule. And related to that, I gave some homework problems. So anybody has tried to do some homework? Raise your hand. Okay, great. So how long does it take? Did it take to multiply 4 by 4? Half an hour? Right, great. So that's what I expected. So we are learning about transpose. Transpose operation is a exchange rows by columns or vice versa. And we denote as a transpose. I-J component is actually A-J-I. So row index become column index, and column index become row index. For example, if A is 1, 2, 3, 4, so A 1, 2 component. So which one is Y 1, 2? 1, 2 is this, right? It's become transpose 2, 1. So and a transpose 1, 1. So 1, 1, if you interchange row and column, it's the same, right? The same as this. A transpose 1, 2 is A 2, 1. And A transpose 2, 2 is A 2, 2. So using this, we can write down the following way. So the 1, 1's element over A transpose is same as A 1, 1, so it's 1, right? 1, 2 is same as 2, 1, so it's 1, 3. A transpose 2, 1 is same as 1, 2, so it's 2 and 4. Right? So it's actually looking like this way. You change this column into this row. And you change this column into this row. And for your reference, we say the subscript over the letter is called the superscript. So in linear algebra, in my class, I'm going to introduce many different kinds of superscript. And so, for example, AT, this is a superscript. A component, it goes down, so it's subscript. So the origin of this word is script from Greek. It's Greek word. Word means word. So script is the origin of script is from word. And I'm not very religious man, but there is a particular word called Holy Script. is the Bible. Transcript, there are many words. Also, script is used as a 대본, something to read. It's called script. So, in modern English, script is mainly used as something to read for the play, movie, or drama. So that's what's called a script. So you learn 4 different English words today as well, right? Script, superscript, subscript. So super is also from Latin, it is from upper. Sub is from lower. So sub can be used in front of a word, and typical word is subway. Also subway. You know what is subway, right? 지하철. But sometimes subway is a brand name for sandwich. And super is used everywhere. Like a supermarket, Superman. So something above. Okay, 2 more pages. The transpose operation is a very interesting property. That is, if you multiply 2 matrices and then take a transpose, the same as multiplying the transpose of B and transpose of A. So the transpose of each matrix in the reverse order. Of course, it can be easily done by using the components, but we can check. This is my favorite matrix form, 5, 6, 7, 8, and good for the practice. So transpose of A, you change column by row. So it's 1, 3, 2, 4. Transpose of B is 5, 7, 6, 8. So let's multiply AB first. 1, 2, 3, 4, 5, 6, 7, 8. So by now you should be able to do this 2 by 2 matrix multiplication very easily, right? Because you already have done, if you have done your homework, complicated matrix like 3 by 3, 4 by 4, 5 by 5. But let's do it slowly. So the first component is 1 times 5, 2 times 14 is 2 times 7 is 14 plus 5 is 19, right? So 19. Second element, 1 times 6 plus 2 times 8, 16, 2, 6, 22. Okay, I'm going to stick to blue. The 2, 1 component is again 3 times 5, 15. 4 times 7 is 28. So 15 plus 28 is 43. And last, 3 times 6 is 18. 4 times 8 is 32. So 32 plus 18 is 50. So AB transpose, let me put some space here. So AB, and if you take a transpose, you just change the column by row. So it's 19, 43, 22, so 50. And B transpose, A transpose is 5, 7, 6, 8, 1, 3, 2, 4. So let's do the same thing again. So first element, this is 1. 1 is missing. It has to be 1, right? So 5 times 1 is 5. 7 times 2 is 14. So 5 plus 14 is 19. Same. 2, 1, 2. 5 times 3 is 15. 7 times 4 is 23. So 15 plus 28 is 43. So 43. Times 1, 6. 8 times 2, 16. 16 plus 6, 22. Great. Finally, we have a 6 times 3 is 18. 8 times 4 is 32. So 18 plus 32 is 50. So if you compare this result with this, they're the same, right? For in this particular case, we have ABT transpose is B transpose A transpose. So in terms of the matrix multiplication, so I think I simply, so let's say abstractly, for n by n matrix, A component is Aij, B is Bij. So AB Ji's component, because AB transpose will be AB. Ij component of AB is by definition is Ji, right? So ABJI is, according to the definition, k equal to 1 to n AIK B K AJ BI, right? It turns out that this is A transpose KJ component, right? And this is B transpose IK component. So these are the components, so we can multiply this way. B transpose IK, A transpose KJ. So this is actually the definition of multiplication, AT, IJ, right? So this is, turns out to be A, B transpose ij. So in the abstract way, it is very easy to show that this is always true for maybe just 4 lines. But in order to build your belief about this statement, you need to do some practice. Right? Very nice. So abstract is nice. We need one more page. So in order to build your face about the statement, I will give you some following homework problems. 1, 2, 3, 4, 5, 6, 7, 8, 9. B 10, 11, 12, 13, 14, 15, 16, 17, 18. To show that, A, B transpose, B transpose, A transpose, explicitly, by multiplying above matrices and their transposes. So that's homework. So I told you homework is for your work at home, and you don't need to turn in. In the first lecture, last week, I told you that we don't have a midterm exam, but we are going to have a frequent quiz, maybe 2 or 3 every 2 or 3 weeks. So to keep my word, we are going to have a first quiz next week. Your first quiz. March 20, right? 11 to 12. So first quiz is usually warming up. So it's very easy. Maybe 80% of the students will get perfect score to encourage you. So it's going to be very easy. So you can prepare 1-page cheating sheet. A4 size, 1 page only. And handwritten. You may need a calculator. Engineering calculator type. But no programming, because it's very easy to, these days it's very easy to program calculators. So input the matrix element and then you just push the button, then it will automatically multiply. So no programming. And dictionary. Because the problem will be given in English. So if the word, so I prefer book form over of a dictionary, but you can bring electronic dictionary as well. But no iPhones, no cell phone, no smartphone is allowed. And most importantly, after the quiz, there is going to be a class. The class resumes after the quiz. So about last year, after the exam, even though I told you that we are going to have a class, half of the students disappeared. So that was actually a perfect timing for surprise quiz. So we also had a surprise quiz for the first quiz, because more than half of the students disappeared after quiz. So it's a perfect opportunity. And read the problem very carefully. So sometimes I gave some very easy problem, such as write your name. But there are several students who wrote my name. So there's usually 5 points score, and then few percent of the class give a wrong answer. So that means you need to read the problem very carefully. So you will be very busy for 1 hour. And the topic covers what we learned last week and today. So any questions about our forthcoming quiz? Maybe it's a perfect opportunity to slow down the progress. I think I'm going a little bit fast. If not, I will move on to the next topic. So actually, the most important topic for this semester is determinant. Or in Korean, it's called 행렬식. And very simple form of determinant probably was treated in your high school math books, such as 수학의정석. So, for example, let's start with a very simple case, 2 by 2 matrix. So determinant is for n by n matrix. So let's say it's 2 by 2. So sometimes I'm going to write down the component explicitly. A21, A22. So determinant of A is written as sometimes this way, or sometimes written as this way. Either way is fine. This notation is defined as A11, A22, minus A12, A21. So anybody who has seen this formula, raise your hands. Let me check your background. So in high school or freshman calculus? All right. So determinant is actually a very simple rule to associate the number to the matrix. So you can regard this as a rule of assigning a number to a matrix. In this case n by n. The matrix itself is a collection of numbers, right? So you have columns, rows, so set of numbers. But determinant actually assign a particular number to the matrix. So it's one of so it characterizes the matrices. So we can do some example. We have many empty space here. So if A is given by 1, 2, 3, 4, then determinant A is 1 times 4 minus 2 times 3 minus 2. If sometimes A is this is a bit more complicated example. If A is 3 over 2, so we read this way: 3 over 2. This is opposite of Korean. Korean is 2분의 3. So in Korean we say denominator first and nominator last. In English it's the other way around. So denominator first, 3 over 2. This is a basic difference in the language structure of 2. Anyway, enough of English class. Let's go back to math. So determinant A is, actually I choose the particular component to make 2, 3 times 4 minus 6 is actually 0, right? So sometimes determinant can be 0, sometimes determinant is non-zero. So that is very important property. So when find determinant A as A11 times A22 minus A12 times A21. So determinant A is 0, we call A singular matrix, square matrix. So obviously when determinant A is non-zero, then we call A as non-singular. So when A is non-zero, A we call non-singular. This is very important because let's just consider particular matrix. A is A11. A prime so A prime so you are going to see the reason why I have chosen this particular A prime. A22 minus A12 minus A21, A11. You just need to multiply them together. So this is A11, A22 minus A12, A21, right? Second element, A11 minus A12 plus A12, A11. This A21, A22 minus A22, A21. And last, A21, A12, A11, A22. So obviously, this is 0, right? And this is 0. And what is this? It's by definition, determinant A, right? This is also determinant A. Because previously we have. So this is a very interesting matrix called determinant A 1 0 0 1. Usually the matrix multiplication is non-commutative. But this particular case, it is not. We are going to see that too. I will let you copy. Still. So usually, if you change the order of the matrices, then the result may be different for the multiplication. And let's see if that is the case or not. So I'm going to do that. This time you're going to interchange the order. A prime is A22, A11 minus A12, A21, A11, A12, A21, A22. So A prime A. A22 minus A12 minus A21, A11. A11, A12, A21, A22. First element, A22, A11 minus A12, A21, right? And this, A22, A12 minus A12, A22. This minus A21, A11 plus A11, A21. Last element, minus A21, A12 plus A11, A22. So again, this goes to 0, right? This goes to 0. And this becomes determinant A. This becomes determinant A. So again, it is A 0 0 A or A times 1 0 0 1. Interesting, right? For this particular case, you can interchange the order without changing the result. New page. So let's summarize what we have been doing. So for example, A11, A12, A21, A22, A prime. Actually, there is a particular name for this matrix, but right now just say A prime. A22, A11 minus A12 minus A21. The interesting thing is something like that. A prime, A prime A turns out to be determinant A times 1, 0, 0, 1. So we are going to denote this particular matrix identity matrix. So identity matrix is actually we know that when you multiply two numbers, if one of the number is 1, then the result is always the first number, right? So 2 times 1 is 2, 1 times 2 is 2. So that's called identity. 항등 1 in for the multiplication. So same as is identity matrix. So let's check if AI A11, A22, A21, A22, 1, 0, 0, 1 is it's easy to see that if you multiply by this identity matrix, it's A11, right? You can do the same thing for second column, first row, second column, A1, 2, A1, 2, right? And for this, you get A21, A21, and A22. So it's A. So if you multiply identity matrix, it doesn't change the original matrix. And let's see if you interchange the order. IA 1, 0, 0, 1, A11, A12, A21, A22, same. It's 1 times A11, A11, right? And this is 1 times A12. And 0, 1, 0, 8 to 1. Finally, 0 times A1 to 0, 1 times A2 to is A2 2. So it's A2 2. Again A, right? So identity has a particular property that when you multiply any matrix by identity, the result is the original matrix. If it is matrix size is bigger than 2, for 3 by 3, identity matrix can be 1, 0, 0, 0, 1, 0, 0, 0, 1, etc., etc. So we can have a following a ij component 1, 0, right? And this particular arrangement is called diagonal component. So the identity matrix can be defined the following way. When the column index and row index are the same, it's 1. Otherwise, it's 0. It can be even simplified using the following notation. We delta I j. Sorry, this has to be j. So this notation means this. Delta I j means when I and j are the same, it is 1. And when I and j are different, it is 0. And this name is called Kronecker delta. Oops. What's happening? Kronecker delta. It's Greek word delta. So this particular property of A prime give a clue to defining the matrix division. So in numbers, 4 divided by 3 is actually same as 1, 3, right? So matrix division is actually the same as matrix multiplication. Gives I. So if determinant A is non-zero, we can define the matrix inversion. This is called inverse matrix. So inverse matrix is defined for 2 by 2 cases A22, A11, minus A12, minus A21. Then A times A inverse. A inverse, A is identity. So analogous way is following. 4 times 1 over 4 is 1, right? In terms of number. So if inverse matrix exists, then we can define matrix division. So in that case, we can say this n by n matrix is close to 4 basic arithmetic operation. And then we are going to spend some time to further study those inverse matrices. So if then the matrix is closed to the 4 basic arithmetic operation. So they were asked for n by n matrices with a collection of non-singular square matrix is close to the four basic arithmetic operations. Then you can define functions out of those matrices, which is a topic for the further in the future. Maybe we can take a break for, I don't know, until you finish, you check your name again. So if you already checked last week, you don't need to. But if you add it after the last week, maybe you better check if your name is here. Okay, we're going to take maybe 5 or 10 minutes break, depending on how many students want to check his name, he or her name. So let's study some of the properties of determinant. Maybe start with So let's study the properties of determinant, in particular 2 by 2, and actually the properties also hold for general n by n. When A you can change the column. A12, A22, A11, A22. And check the determinant. Determinant A prime. Of course, we know that determinant A is A11, A22 minus A12, A21 for 2 by 2. Determinant of A prime is actually A12, A22, A21 minus A11, A22, which is a minus over determinant A, right? And if we change the row, what happens? A double prime, A21, A22, A11, A12, determinant A double prime, A21, A12 minus A11, A22 is minus over determinant A. So the first property that we discovered is that if you interchange rows or columns, then the determinant changes by sign. So if the rows, if two rows exchange the determinant changes by the sign. The first property, if you interchange any two rows or any two columns, then the resulting determinant changes the sign. Change the sign means you put minus. Another interesting case is if any two columns or two rows are identical. So for example, if A prime is given by AB, AB. So in this case, two rows are identical, right? Then determinant A prime is AB minus AB is equal to 0, right? Or two columns identical. AC, AC. So identical columns. This is identical rows. Then of course determinant A, AC minus AC is 0, right? So if two columns or two rows are identical, then the resulting determinant is 0. So property, if two columns or two rows are identical, then the resulting determinant is 0. Or sometimes we call null. So in mathematics, null is 0. Null. Null, when I say null, is 0. But actually, you use that particular word in your everyday conversation. 널널하다? Right? You sometimes say 널널하다, right? So I have zero things to do. So probably, I don't know which one is first. So in mathematics, null has been used for a very long time, maybe over 50 years. And the particular phrase 널널하다 has been used, I don't know. When I was in your age, there was no such expression. So it must be like the last 40 years, something. 널널하다, 널. Good, right? Another property 3. You can multiply one particular row by some constant. So one column has been multiplied by some constant k. Then determinant A prime is KA11, A22 minus KA21, A12 is K times A11 A22 minus A21 A12 is K times determinant A. Or you can multiply a particular row by some constant, A double prime, say K A11, K A12, A21, A22 is again K A11, A22 minus K A12, A21 is K times A11, A22 minus A12, A21 is K determinant A. So a particular column is multiplied by some constant. Particular column or row is multiplied by a constant. Maybe I can use the same space. The resulting determinant is multiplied by the same constant. From the original determinant. Very long paragraph, sentence. So if a particular column or row is multiplied by a constant, then the resulting determinant is multiplied by the same constant from the original determinant. So even though it is a long sentence, so the meaning should be obvious to you. I think you will need time to decipher my handwriting, and mine is not very good. So can I move on to the next slide? So 4. The A is A11, A12, A21, A22. If you like to add one particular column by a new column, say A prime, A11, A21 plus B11, B21, A22. So if a particular column is added by another column, then determinant A prime is A11, B11, A22. Let me see. Sorry. A11 plus B11, A22 minus A12, A21 plus B21. So it is A11, A22 plus B11, A22 minus A12, A21 minus A12, B21. So it is A11, A22 minus A12, A21 plus P11, A22 minus A12, P21. The first one is a determinant of A11, A12, A21, A22, plus this is the determinant of a new matrix that the original column has been replaced right? The second one is a determinant of a matrix in which the original column has been replaced by this new column, right? So, and then you can do the same thing for the row. So maybe I can move on to the next page, or maybe make a conclude if column is added by another column, the resulting determinant is the sum of the original one, the determinant, and the determinant I don't have enough space, and the determinant can you read this if I write it of matrix in which the original column is replaced by another one, by the new one. Can you read? Another long sentence. So it is, if you add a particular column by another column, new column, then the determinant is the sum of the original determinant and the determinant of a matrix in which the original column has been replaced by this new one. So this is a sentence. Bit too long, but should be okay. So my writing is same as my speaking, my talking, my words. And actually, the same thing is true for if you add particular rows. And can I move on? So A, maybe I should save the space. A11, A12, A21, A22. A prime is say A11 plus B11, A12 plus B12, A21, A22. Determinant of A prime is same. A11 plus B11, A22 minus A12 plus B12 times A21 is A11, A22 plus B11, A22 minus A12, A21 minus B12, A21. So we can rearrange the terms by the following way: A22 minus A12, A21 plus B11, A22 minus B12, A21. So this is actually determinant of original one. B11, B12, A21, A22. So we can say the same thing. If you add a row by another row, if you add a row by another row, then the resulting determinant is the sum of the original determinant and the determinant of a matrix in which a row has been replaced by a new one. So am I going a little too fast? It's okay? I mean, it looks like an English essay class rather than math. So let's do some practice with this knowledge. So how many properties? Property 5. So these are the most important properties of determinant, and then we are going to utilize it as an example. So looks like my handwriting looks okay. Is it? Or oh. Some. Okay, so the most obvious properties of determinant from those are determinant of AB determinant of the product is a product of a determinants. Or in English. So let's check. We can do a simple way. Determinant A, 4 minus 6 is minus 2. Determinant B, 40 minus 42 is minus 2. So determinant A, determinant B is 4. On the other hand, AB, 1, 2, 3, 4, 5, 6, 7, 8. I think I have done that before, right? 13, 14. 5 plus 7 is 19. 6 plus 16 is 22. 3 times 15 times 28 is 43. 18 plus 32 is 50, right? So determinant AB, 50 times 19 minus 43 times 22. So 19 times 5, 0. 41, 43, 22, 86, 86, 6, 4, 9, right? So that is 950 minus 946, 4. Very good, right? But this is too easy. But can you do it abstractly? So I can move on a bit. With the page AB, B, B11, B12, B21, B22. So AB is actually this A11, B11, A12, B21, right? Element. A21, B11 plus B2, A22 A22, B21, right? And this A11, B12 plus A12, B22, A21, B12 plus A22, B22. So we can regard this as we have a new column, right? So determinant of AB sum of the original determinant, that is this A11, B11, A21, B11, A11, B12, A21, B12, plus A12, B22, A22, B22, plus a determinant of a matrix in which the original column has been replaced by this. Maybe battery is out. So second determinant to start with that column. A12, B21, A22, B21, and A11, B12, A12, B22, A21, B12, A22, B22. However, this can be also regarded as a new column, right? So we can expand further. I think I have to write down with a small letter. So A11, B11, A21, B11, A11, B12, A21, B12, plus that column has been replaced by the new one. So A11, B11, A21, B11, A12, B22, A22, B22. I think we need some space here. Plus A12, B21, A22, B21, A11, B12, A21, B12, and plus A12, B21, A22, B21, A12, B22, A22, B22. Tricky. The problem is I have to start with this 4 determinant in the next page to expand. That means I have to rewrite those, which, so what I'm going to do is very nice. So if I push this, there is a edit, copy, and next page. Can I move on? Again. Copy the whole thing. And I click this. Then edit. Add the clip art and let me check if there is a paste. I can move this up. Maybe not this one. Maybe this. This one? Okay. Clip out. Which one is which one? I think this one. Right. Oh, no. Not this one. Okay, so let's go back to this clip art. business. Or this. I must be. Oh. Not this one. Clear box. I must be able to find this clear box. Where is it? Maybe it's this orange copy. So go to this ribbon. Okay, done. And what I need to do is I can move this and enlarge a little bit. Right. Very clever. So what happens if a particular column is multiplied by the same constant? Then you multiply the whole thing, right? So this is a B11, A11, A21, A11, B12, A21, B12. Same. So this is this. P11, A11, A21, A12, B22, A22, B22. Plus the third one is also multiplied by the same constant. So B21, A12, A22, A11, B12, A21, B12, and this is B21. B21, B21, A12, A22, A12, A22, B21, B21. And then you can do it again for the, this is also again constant, right? Also this is constant, this is constant, this is constant. So you multiply the whole thing by this constant, B11, B12, A11, A21, A11, A21, plus B11, B22, A11, A12, A21, A22, plus B21, P12, A12, A11, A22, A21, plus P21, well, something is wrong, P12, P11, P11, 21, B21, B21, no, B22, B22, right? B22, A12, A22, A12, A22. Right. In the first determinant, two columns identical, right? So any matrix with two columns identical, 0. The last one is also identical, is 0. This is determinant A, right? This one, this column has been replaced, exchanged, right? So this is minus A. So this is determinant A times B11, B22 minus B21, B12. So this is determinant B. So this is A, B. So we just show that the product of the determinant is the product of the determinant of the products, the same as the product of the determinants, by just expanding the determinant using the 5 properties that we have studied. And it can be extended to, say, A B C then determinant of ABC is determinant of A, determinant of B, determinant of C. So they can be very easily proved, and I will give you as a homework for you. So 2 by 2 by 2 will be 8 by 8 matrix. And no, still 2 by 2, but 2 by 4, 8 subdeterminant. I think we will take about 1 hour at your home. So that's good practice for improve your skill for the matrix multiplication. Maybe we can take a break for a few minutes. And then I'm planning to stop the class by 1:30 because you can still have a lunch at the cafeteria then, right? I found this one until 1:50. Yeah. 아까 한 콜라보다 콘스탄트 높여주면은 BB니까 이 콜라보다 이거 똑같이 예. So 2 by 2 matrix, determinant A is defined. So how can you define the determinant if it's larger than 2 by 2? So that's a bit complicated. So we need to have some theoretical extensions. So we first define minor. It's a determinant of a matrix. And of course, for 1 by 1 matrix, determinant A is simply A. So 1 by 1 matrix, we have only one component, right? So for that matrix, we define determinant as just element. For 2 by 2, we define this way. And in order to extend the definition of determinant for 3 by 3, 4 by 4, we first define the notion of minor. The determinant of a matrix formed by deleting ith column and jth column. It's called minor. So minor is a determinant of a matrix in which was obtained by deleting the ith row and jth column of the original matrix. Of the So for example, let's start with 2 by 2, which is easy. So A11, A12, A21, A22. So minor matrix M11. So minor is a determinant of a matrix, deleting the first row, first column, right? So we have 1 by 1 matrix, which is A22. So A22. 1, 2 is you delete the first column, first row and second column. First row, second column, you have this, right? A21. M21, you delete the second row, first column, and you have this, right? A12. M22, you delete the second row, second column, you have A11. And you define cofactor matrix, Cij. This is called cofactor. So C11 is simply -1, 1 plus 1. So what is -1 to the 1 plus 1? It's plus 1, right? A22. C12 is minus 1 to the 1 plus 2, M12. Minus 1 to the, we call minus 1 to minus 1 to 1 plus 2. We call. So what is minus 1 to 1 plus 2? It's minus 1 to 3. It's minus 1. So minus A 21. C21 is minus 2, 2 plus 1. M21 is minus A12, right? C22 is minus 1 to the 2 plus 2. M22 is M11, A11. To summarize, C11 is A22, C12 is minus A21, C21 is minus A12, C22 is A11. This is your cofactor. So let's summarize. C11 is A22, C12 is minus A21, C21 is minus A12, C22 is A22. So determinant A is actually for 2 by 2, A11, A22 minus A21, A12, right? So we can write this way. A22 is A11, and then you can replace A22 by cofactor component, C11, minus A12, A21 is C12. Or this way, A22, A11 is C22, A22, plus A12 is C21, A21. So A21, C21, A22, C22. We can express in many different ways. So in general, determinant A, so this can be written as a sum of k equal to 1 to 2, A1k, C1k, right? So this is written the same, k equal 1 to 2, A2k, C2k. So using this simple property, you can define the determinant for general case. General. Determinant A can be A1k, C1k, or A2k, C2k, or in general A I K C I K or A K J C K J. It's I 1 2 3 N. J is 1 2 3 N. That's your general definition of a determinant. So let's try to calculate the determinant for 3 by 3. Am I going too fast? A bit too fast? So minor and cofactor are almost essential thing to understand the determinant. So maybe a little bit too abstract. So I will try to do some actual 1 0 1 2 3 4 5 6 7. So determinant A can be written as either way, AIK, CIK, or AKJ, CKJ. So you can choose either row or column with the largest number of zeros. So in this case, I can choose this column, this row, because already one component is 0, right? So we just need to calculate the two cofactors. The determinant A is actually 1 times cofactor. So this is A11, right? So it's a C11, 1 times C13. So C11 can be formed by this minus 1 to the 1 plus 1. You delete the first row and first column. So this 3, 4, 6, 7. Which is 21 minus 24 minus 3. C13, you delete the first row, third column, so this is your minor. And minus 1, 1 plus 3, and 2, 3, 5, 6. So minus to the 1 plus 3 is plus 1. 12 minus 15 is minus 3. So determinant A is actually minus 6. So you can calculate the determinant using minor, cofactors, and original element. Another example. A 1, 2, 3, 0, 1, 0, 4, 5, 6. So in this case, which column or which row do you like to expand? Second row, right? The second row has 2 zeros, so you only need one cofactor. So determinant A is actually 1 times co 2, 2, right? So 2, 2 is you obtain second row, second column, minus 1, 2 plus 2, 1, 3, 4, 6. So minus 1 to the 2 plus 2 is 1, and this is plus 6. So now it is obvious that the first quiz covers up to calculation of the determinant. So I will give a homework. 4 by 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Determinant A. So this will be a very good homework for forthcoming quiz. If you can do this, then you can calculate any determinant by hand. For your information, I think it will take about 2 hours. Because there is no 0 entries, right? So you need to have 4 cofactors, which is 3 by 3. And also each cofactor is an actual determinant, 3 by 3 determinants, but there's non-zeros. So you need to calculate 6 actually 2 by 2. Maybe about half an hour if you do it fast, or otherwise maybe 1 hour. What else do we need to cover? I can show you some of the things that we can, how to do that. So let's A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I partially failed your homework. The determinant A is actually, you can expand this first row. So 1 times C11 plus 2 times C12, 3 times C13, 4 times C14. So that is C11 is you delete the first row, first column, so this is your determinant. So 1 times 6, 7, 8, 10, 11, 12, 14, 15, 16. 2 times, this is minus 1 to the 1 plus 2, right? And then you delete the first row, second column, first row, second column. So you have this 5, 7, 8, 9, 11, 12, 13, 15, 16. And 3 times minus 1 to the 1 plus 3. You delete the first row, third column. So 5, 6, 8, 9, 10, 12, 13, 14, 16. Plus 4 times minus 1 to the 1 plus 4. You delete the first row, first column. 5, 6, 7, 9, 10, 11, 13, 14, 15. So you have to calculate this 4 3x3 determinant, and then do the same thing again, right? So you need 3 cofactor each. 3, 3, 3, 3. So 12, actually 12 2x2 determinant. So I think maybe it'll take about half an hour to 1 hour. It can be fun homeworks. So you fill the rest. And then as homework. Maybe I can stop today here. So I will let you prepare less subject to study. So next week we are going to have a first quiz for 1 hour from 11 to 12. And then after the quiz, we are going to have a class. Okay? So enjoy your lunch. And I'm going to post the class YouTube today.
첫 번째 앞에 주신 홈워크에서 구하는 거에 대해서 만약에 퀴즈에서 이렇게 답을 한다면 이것도 괜찮을 것 같아요. 혹시 디터미넌트 ABC 곱한 확률 ABC로 곱한 구하는 문제인데 이거를 그냥 얘네 둘을 AB를 취한한 다음에 이거 두 개가 두 개의 곱이라는 거는 통일되니까
다 써줘야 돼.
다 써줘야 되네.
시험에 나오면 다 써줘야 돼.